So hello everyone, let us solve another LeetCode problem, and the problem name is count subarrays with score less than k. So let us read the problem statement. So the scores of an array is defined as the product of its sum and its length. So they have given this example. So the score of this particular array 1, 2, 3, 4, 5 is nothing but the sum of all the elements inside it multiplied by the length of the array. So in this case the length of array is nothing but 5, so we multiply it by 5, so we get the score as 75. So this is the definition of score of an array. Now what the question need us to find out is the we are given some positive integer array nums and an integer array k. Now we need to return the number of non-empty subarrays of nums whose score is strictly less than k. Now strictly less than k means nothing, like everything which is less than k, not less than or equal to k, only less than k. So that is what strictly less than k means. Now then they have given the definition of subarray, which is very basic. So let us see this first example and try to understand the question and try to find some solution out of it. So this is the first example that they have given, and the nums array is 2, 1, 4, 3 and 5, and k value they have given is 10. So we need to find out all the subarrays, all the non-empty subarrays whose score is strictly less than 10. So in this case the output given is 6, and first of all let us find out what are those subarrays, then we will think how to find those count of the subarrays. So you can see that okay, 2 is here, so this 2 in itself is a subarray, and the score of this subarray is nothing but 2 into 1 because the size of this subarray is 1. So yes, we can say that the score here is 2, which is less than 10. So this is one subarray. Similarly 1, 4, 3 and 5, these in itself will also be considered as the subarrays whose score is less than 10, because obviously 1 into 1, 4 into 1, 3 into 1, similarly 5 into 1, these all are less than, or these are strictly less than 10. So we can say this 1, 2, 3, 4 and 5, these are the 5 subarrays which were of size 1. Now let's say let us take this subarray 2 and 1. So let us take this subarray 2 and 1. So the sum here is nothing but 3, and the score will be nothing but the sum into the length of this subarray. So sum here is 3 and the length here is 2, so we get 6, which is strictly less than 10. So we can say that okay, this is also one kind of subarray. So till now how many subarrays are there whose score is strictly less than k? So this was 1, 2, 3, 4, 5 and 1 we got here. So till now we got 6 subarrays. So let us see if we can check we can find another subarrays or not. So let us take this 2, 1 and 4 subarray. So let me just erase this. Yeah, so let us take this subarray 2, 1 and 4. So the sum of this subarray is nothing but 3 plus 4, that is 7, and the score will be 7 into 3 because the size of subarray is 3, so the score will be nothing but 21. So this is not strictly less than 10, so this will not be into our account. Similarly, if this 214 is not the score is not strictly less than 10, we can't say that this subarray will also have the score less than 10, because obviously we only have the positive integers. So if one particular subarray, let's say this was the subarray 214, its score itself is not less than 10, so how we can obviously say that anything added positive will also not give a score strictly less than 10. So this was the kind of observation, and let us check if we can find some another subarray or not. So let me just erase it out for better understanding. So yeah, we have considered the single subarrays, or then we have considered this 2 1. So these were the 6 subarrays. We have also like considered this particular 2 1 4, which was not included. So obviously if we include these elements, anything higher will not be considered as a subarray whose score will be less than k. So these will also not come into account. So we have one option to take care is 1 comma 4. So let us check that. So 1 comma 4 is the next subarray. So the sum of this subarray is 5, and the score here will be, because the size of subarray is 2 and the sum is 5, so we can say that okay, the score here is 10, but we will still not consider into our account because we want strictly less than 10. This is not strictly less than 10, this is less than or equal to 10, or rather I should say that this is equal to 10. So we will not consider this into our account. Similarly, if this array's score is not strictly less than 10, we can say that these subarray will also not have score less than 10 because it is obvious. So the next arrays that comes into our mind is like 4 comma 3. So let us check for 4 comma 3. So let me erase that. So 4 comma 3. So sum here is 7 and score here would be nothing but 7 into 2, that is equal to 14. This is not also gonna consider because score is not strictly less than 10. So obviously 4 3 5 will also not be taken into our account. Now the only left subarray with us is 3 comma 5. So let us check that. Now that is also not gonna be like considered because sum here will be 8 and score here will be nothing but 8 into 2, that is 16. So this is also not considered. So we find 6 subarrays whose score was strictly less than k, and k in this for example is 10. So our answer is 6 and the output is also 6. So yeah, we understood the question in the correct way. Now let us find out what can be the possible solution. Now the possible solution can be sliding window. Now why sliding window? Since the question needs us to find out the subarrays and we need to do some computations out of it. So whenever there is a question which want us to find out subarrays and there is some counting involved in it, counting here in this case is nothing but the calculation of the score. So whenever there is a question in which we want to find out the number of subarrays and also there is some kind of calculation involved, even though it is not involved in some cases, but still we can say that. So in these kind of question we tend to use sliding window. So let us see if this sliding window approach works or not. Because we can't just directly say okay, the question is of subarray, so just apply sliding window and we will gonna have our answer with us. So let us first try out will we get our answer with that or not. So let us find out. So let us take this same example and try to run sliding window solution onto this. So this is 2 1 4 3 and 5. So in the sliding window approach we have 2 pointers, I and J pointer. J keeps on moving and I pointer is used to shrink a window according to the some condition which we will make out. So initially we will take some variable which will be initially 0, and as J moves forward we will keep on adding the corresponding element to our sum and try to figure out what is the score. So currently J is at 2, so we will add 2 to our answer and sum will now become 2. Now we will calculate the score of this particular subarray which is from I to J. So the score here will be nothing but the sum which is 2 in this case, and into size of the subarray. So size of subarray is nothing but j minus I plus 1. So score will be here in this case 2 into 1, which is equal to 2. So yes, this is one particular subarray which we find out. So we will keep one answer variable, and currently it will be 1. Now j will be moving forward and j will be pointing to 1, and now our window size is 2, 1. Now again the sum will be updated by adding 1, so sum will now become 3. So let me just write it clearly. Yes, so sum is now 3. So score will be now become so let me erase this. So score will now become 3 into size of the subarray. Size of the subarray is j minus I plus 1. In this it is 2, so it will become 6. So yes, this is also less than k. So we will now move our j pointer again forward, but before that we will update our answer by adding one subarray, which is 2. But wait, this is wrong. We move to this particular subarray. This is our current subarray, but before that we have came across this subarray in which we found 2, but that is not correct. This is the subarray and this entire is the subarray. But wait, what about this subarray? This one in itself is also subarray which is less than, whose score is less than k, but we didn't take that into our account because we just kept on increasing. We didn't consider the subarrays which could be possible by adding that particular element. Let me explain. So this was the initial subarray. Now if when we increase our window size, this become our new subarray. But what happens by adding this element? This element is also a kind of subarrays. Let me give you another example. Let's say we have some kind of subarray till now as 2, 1. Let's say we again added some element called 1 in it. So by this element added, there will not only one subarray be newly formed, not this only the subarray. There will be more subarrays formed, that is this particular entire subarray, then these two as particular subarray, and this one single alone as a subarray. So total, by influence of one element, how many new subarrays can be formed? That is nothing but the size of the subarray. Now what is the size of subarray? Size of subarray is nothing but j minus I plus 1. So this is the most important thing which we need to figure out in this particular approach. So let us again check for 2, 1 window, then we will move forward. So I pointer was at 2 and j pointer was at 1. So the subarray we got here is 2, 1. So again the sum was 3 here. The score would be 3 cross 2, that is 6. So yes, this is a subarray whose score is less than k. So we need to add what to our answer? We need to add j minus I plus 1 to our answer, because by influence of one element there can be these many new subarrays can be formed. So instead of adding 1 every time, we will add j minus I plus 1 to our answer. So initially our answer was 1. We added j minus I plus 1. In this case it is nothing but 2. So we added 2 to our answer. So our new answer will become 3. Now we will move forward with our j pointer. Now j pointer is at 4. So our new subarray will be 2, 1, 4. Yes, so sum will now update to 7. Now score will become 7 into 3, that is 21. So this is not acceptable because this is not strictly less than 10. Now it's the time to shrink our window, because obviously if this array is not valid, obviously the elements obviously the subarray by adding some elements in the same subarray will not give us the correct answer. So now it's time to move our I pointer ahead. So I is here, our new subarray is 1, 4. So sum here will be 5. Score will now become 5 into 2, 10, which is not strictly less than. So this will also not consider into our account. Now we'll move forward. I will be here. Now I is at 4 and j is also at 4. So our new subarray is 4. Sum will be 4 and score will also be 4. Yes. So we can count this into our answer. But what we need to add? We need to add j minus I plus 1 to our answer. Now here it is size of subarray is 1 only. So j minus I plus 1 will also be 1. So we added 1 to our answer and our new answer will become 4. Now we'll move our j pointer because this is the correct position for I. Now j is here. Obviously 4 comma 3 will also not be added into our subarray because sum is 7. 7 into 2 will be 14, which is not strictly less than 10. So now we'll move our I pointer. Now I is at 3, j is at 3. Okay, this is a valid subarray because score is 3 only. So we will again add 1 to our answer. Now again we will add move j pointer ahead. Now our subarray will be 3 comma 5. 3 comma 5 sum is 8 and score will be 8 into 2 16. So 16 is also not strictly less than 10. So we will not consider this into our account. Now I pointer will move to 5. So I is at 5, j is at 5. Sum will be 5 and score will also be 5. So yes, we will again add 1 to our answer. And now the answer will become 4 plus 1 plus 1, that is 6. And hence we got the correct output with the help of the sliding window approach. So yes, we can say that sliding window is applicable here. Only one thing to notice: whenever we whenever with the influence of one element, we need to add j minus I plus 1 subarrays to our answer. This was the most important thing or the most important part here. So yes, let us understand in more better way with the help of the code. So let us see the code now. So we have initialized one result which is nothing but the final answer that we need to return. This is the I pointer, this is the j pointer by which we will approach for. This is the basic 2 pointers for the sliding window approach. I pointer will help in shrinking the window and j pointer will help us in expanding the window. So this is the initial sum because obviously for calculating score we need sum into the length of the subarray. So this is the initial sum that we will take into our account. Sum will be initially 0. Now we will approach the sliding window. J will be keep on moving forward until this condition hits. So sum will get updating itself with the jth element of the nums array. Now whenever we find any condition where the score, this is nothing but score, sum into j minus I plus 1, this is nothing but score. So whenever our score exceeds or becomes equal to k, this is the condition where we need to shrink our window size or we need to move our I pointer ahead. So what we will do, we will move our I pointer ahead, but before that we will remove that particular element from our sum, and this will keep on happening until our subarray sum or subarray score is greater than or equal to k. Once it gets satisfied, then we will continue the flow by keep on adding the we can keep on adding the number of subarrays to our final answer, and in the end we will just return the result. So this is nothing but the important thing that we have seen in the drawing explanation part, the addition of j minus I plus 1 into our result. This way. Yes. So yeah, this was the code similar to what we have seen in the drawing explanation part. So I hope you understand this problem. So thank you.